Hi, my daddy is going to do science for you.
Okay, take it. I turn it around quickly. Hi guys, how are you all doing? So today we're going to do Hooke's Law, and we talked about it in class already. You're going to do this in your lab section of your book. As I've done it, you're going to have your title, your materials, your procedure, the table, and your conclusion. Okay, and you need to draw a graph. So here, Sophie, come in closer. Here are your materials. A retort stand, here's my retort stand. Spring, here's my spring. 50-gram weights, here are my 50-gram weights, which I will add later on, and a ruler in the background. So come over to this side, come over to the other side of me, Sophie. Okay, good. So the first step is, I'm going to set up the spring as above. So here's my spring. Can you zoom in here, Sofinka? There. So at the moment, I'm going to use this marking here, and this part of the spring is at 3.5. So on my table here, I have mass 0 grams. Can you see this? Come over this side. Mass 0 grams, which is force is 0. The reading is 3.5. So I'll be using this 3.5 for the rest of my readings. Okay? Cool. So I want to add 50 grams. Here's 50 grams, Sophie. Can you get that one in? That's 10, 20, 30, 40, and the whole contraption is 10 grams. So I'll bring it up here, and we can see it's extended down. Okay, can you zoom in, Sophie, again? It is now reading at 4.5. So over here, 50 grams is 0.5 newtons, and is now reading 4.5. Okay, that's the new length. So we must calculate the extension by saying 4.5, take away 3.5, and that equals 1. So it is now extended 1 centimeter at 1 force. The next one, 100 grams. So I put on another 50 grams up here again, Sophie. Put 50 grams on. Okay, it extends down again. So we take your reading. Can you get the reading in here? It looks like about 6.7. So write down 6.7 into my notebook here, 6.7. You can do the rest. Okay, it's easy enough for you. I added another 50 gram weight. Bring it up here again. Okay, I wait for the spring to stop. It is now, zoom in here, Sophie, a bit again. It's now reading 8.9. So 8.9 is here. So 8.9 take away 3.5, and that's your new extension. Okay, this is 50 grams here. So can you bring it up here again, Sophie? That's, oops, that is 10, 20, 30, 40, and 50. Okay. The new length, can you zoom in here again, Sophie? Is 11 exactly. 11. So I've done 11.0 here. You will do 11.0, take away 3.5, and that's your new extension. The last one is another 50 grams of weights, which I put on here. That's a bit better than the last one. It's a bit smoother. Wait for the spring to stop springing. And can you zoom in here again, Sophie? And it is about 13.3. It's just still a bit springing, but so I just want to do it quickly. So 13.3. So once again, you do 13.3, take away 3.5, get your new extension. Okay, good. Then, here's my table, here's my graph. Here's your force. So you will plot force versus extension. So the first point will be 0, and extension is 0. There's no extension on it. So 0. The next point will be at 0.5, which is here. It went 1 centimeter. So 1 centimeter, so 0.5. And that's 1 centimeter. That meets around there. Okay? You will do then 1, whatever 1 was, and upwards this way. 1.5, out, and up. So you should have a nice, hopefully, straight graph. A non-uniform graph should be proportional. Okay? So one more time, fill out your procedure. I'll hold it here steady for you. Here's your table at the back. So I want you to fill in these. Okay. And then fill in the graph. Okay, here's your force on your y-axis and extension on your x-axis. It is also on page 440 and 441. Right, guys. Thank you very much for listening, for looking at your homework. I'll explain again, and talk to you soon. Thank you.